Chapter 1, the Pythagorean theorem as it applies to the distance formula and the equation of a circle. This will only be pages 1 through 3 of your notes, and I'm not sure that your notes will have all the correct notation in it. When we get to board 3, I can't remember if they were corrected after they were typed. Okay, the Pythagorean theorem. It doesn't matter how you draw it. You can draw it upside down, kitty-cornered, but we usually call one leg A, one other leg B, and we call the hypotenuse C. And you know that A squared plus B squared equals C squared, and you realize that A, B, and C are positive. These are magnitudes. And sometimes you'll see me just write leg, hypotenuse. And so it's the length of leg 1, whichever one you want to call leg 1 squared, the length of leg 2 squared, and the length of the hypotenuse squared. Now, an interesting fact about that you need to know to help you understand the vocabulary is the Pythagoreans were weirdos. They worshipped the right triangle and the right angle. In fact, the right angle always pointed towards the heavens. So when they drew the triangle, the hypotenuse would be along the ground and the legs would be pointing upwards, making the right angle pointing to the stars, the sun. Now, hypotenuse is a Greek word, and hypo means under, and the tenuse part is our word for where we get tension or stretching. And so hypotenuse means to stretch under. It meant to stretch under the right angle. Hence, when you ask, why does that the stupid word hypotenuse and why do I have to learn it? It means nothing. It actually means exactly what it's telling you to do. And so you will see that all words eventually have a practical meaning and they have reasons for why they are what they are called. They come from many different languages. For example, like algebra comes from the Arabic language. So now, the Pythagorean theorem is about lengths, also known as magnitudes. Another magnitude that we discussed in section A was distance. And we realized that the distance between two numbers is the absolute value, or you say the biggest minus the smallest, because if you do the biggest minus the smallest, you always get the absolute value. Now, please understand that we're in the real world, so all lengths are positive. Therefore, you cannot have a negative quantity in the distance formula. I personally loathe the notation they use in the distance formula, which is the quantity squared, because it does not represent the true truth, and it actually gives you a lie, even though mathematically they're equivalent. So, for example, 2 minus 8 is negative 6. Is that really a length? No, it's not a length because it's negative, and so it doesn't represent truth, even though the final answer, 36, will turn out to be a fair-haired child. 8 minus 2, on the other hand, is positive, and this represents a length and hence truth. Now we know mathematically when I square, it doesn't matter whether you're negative or positive. But why I loathe this originally is that you turkeys, when you go to square negative 6, you'll do it on your calculator without a parenthesis and you get negative 36 and you start whining, oh, negative 8 squared is negative 64, negative 5 squared is negative 25. No way, no how, no time. A negative 5 when I square it is still a positive 25. A negative 8 when I square it, negative 8 times negative 8 is still a 64. Therefore, when I desire the length between x1 and x2, I must write it as an absolute value. So you realize that this is truth, and truth is truth. Do not lie to me. Now, you will find we will go with the parenthesis notation, but since that is what has been adopted as standard in math, but I needed you to understand truth. Now, let's see the true distance formula, known as the Pythagorean theorem. Here's your leg, hypotenuse, We know it's the length of a leg squared, the length of the other leg squared added together. That sum is the length of the hypotenuse squared. Now I'm going to take any 2 points that are in the I'm going to take any 2 points that are in the Cartesian plane, that is the coordinate plane, because they're dumbing down America again. The Cartesian plane was created, your axes X and Y, by a man called Rene Descartes that made geometry and algebra come together so we could actually think better. But now they just call it the rectangular plane or the coordinate plane because, heaven forbid, they assume you all aren't smart enough to know. But anyway, and we'll assume that these 2 points are not on the same axes. That is, they're not both on the X or both on the Y. And I want to find the distance between these 2 points. This is representative. I have this one going downhill. It could just as easily go uphill. Nobody gives a diddly. And so this is x1, y1, and down here I should have written x1, y2. In this little corner, I forgot. That's okay. So how far apart are x1 and x2? There is the length. How far apart are y1 and y2, which is the vertical? There is the length. That's the distance. So technically, the distance formula, which is the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, is the distance squared plus the distance squared equals the distance squared. So this is the x leg, the y leg, or the x length, the y length, and then the hypotenuse length. So the length or the distance of the hypotenuse is this. Now again, I know you're going to just use parentheses in there, but I want you to realize when you're doing these, I never want to see a negative number in the formula, and you'll see what I mean in a few minutes. Now, in math and science, they use the Greek symbol for the letter delta to represent change in quantities. So I could have just easily written it this way: the change in y's length and the change in x's length. And I end up with this formula, which many of you see in science class, not necessarily in math class unless you're in my room. Now, a lot of you struggle with finding the positive distance. Those are real world distances, magnitudes, between two numbers. But yet you don't struggle with the temperature change. So let's play the temperature game. Suppose I want to know what's the difference between 2 above 0 and 7 above 0. And you tell me it's 5. If the temperature goes from 2 to 7, you say it went up 5 degrees. If it goes from 7 to 2, you tell me it went down 5 degrees. But when I say what is the actual change in temperature, you just say, oh, there's a 5-degree change. Now over here, what is the change in temperature from 1 below 0 to 5 below 0? Well, you say that, that net change is 4 degrees. Now, if I went from -1 and I dropped to -5, you would say, oh, I went down 4 degrees. If I went from -5 to -1, you would say, oh, I rose 4 degrees. Still no issue. Now, what happens when I come to this problem and I'm 4 below 0 and I'm 3 above 0? Well, just look. Between 0 and 3, the net change is 3. Between 0 and -4, the change is 4. That is, its distance. I either went 4 up or I went down. But what's the total change is 7. Notice these had opposite signs, so I ignored the sign, that is, took their absolute values, and I added. Over here, they had the same sign. I took their absolute values, that is, I just ignored the signs, and I did large minus small. So remember, magnitude does not have a sign. It does not care whether the temperature went up or down, rise or falling. It really doesn't care left, right, diagonal. Nobody cares. It just wants the positive change. So when both numbers are positive, you just do what comes automatically, large minus small. When both numbers are negative, you ignore the signs. That is known as taking the absolute value, and you do large minus small. When you have opposite signs, you ignore the signs, known as absolute value, and you add the numbers, because you said the change was, well, I went 3 above, I went 4 below, so 3 and 4 is 7 once again. So let's look at a couple of examples. I have 2 and 15. They're like signs, 2 and 15. So I take large minus small, and the change is 13. -6 and -11, they're like signs. Their absolute values, or ignoring the signs, are 6 and 11. I take large minus small, and I get 5. 8 and -4, they're unlike. One's above and one's below. So I need to add the above amount and the below distance, and 8 plus 4 is 12. So honestly, before the calculator dependency, folks did this automatically. We had what was known as number sense, which is right up here. Both above, subtract, both below. Absolute values or distances subtracted, big minus small. One above, one below. Find their distances from 0 and add. All right. With this in mind, and let me tell you, over my 44, 45 years of teaching at Bloom High School, trust me, people struggle. Now, I want you to find the distance between 2 points. I usually write one ordered pair on top of the other. Doesn't matter which way you do it. This is the only one I'll do both ways. How far apart are the x's? Well, one's 2 above, one's 5 below. Total distance is 7. The y distance, they're both below, so 4 and 1 gives me 3. It doesn't matter which way you did it. No one cares. We see that the x length is 7, the y length is 3, and so using the Pythagorean theorem for hypotenuse, it would just be 7 squared plus 3 squared, which gives me square root of 58. Notice I drew the little triangle so you could put it in. Again, you can draw this triangle any way you want as long as you have 3 and 7. 3 will be vertical distance, and 7 is the horizontal distance. Next problem. Again, I put one ordered pair on top of the other. I don't care which one you put on top, which one on the bottom. How far apart are the x's? Well, from -5 to -3, a change in 3 degrees, so it's 3. From 12 to 16 is a change in 4. So I have 3 squared plus 4 squared. You should know that's 5. You've all had geometry. You should fall in love with the 3, 4, 5 right triangle. Get to know me. Also, another triple you should know is 5, 12, 13. And the last one that should be in your memory banks is 8, 15, 17. Why? SAT and ACT all assume that you have those in your memory banks. Next one, I simply put one on top of the other. This is 1 below, 5 above. 1 and 5 is 6. This is 2 above, 4 above. The difference is 2. 6 squared plus 2 squared, I can do brute force. 36 plus 4, 40. 4 times 10, 2 root 10. Or something that I will constantly impress on your brain, because what if you don't have that beloved calculator? It is the non-calculator section of the SAT. This is a pretty dippy problem, folks. What do 6 and 2 share? 2. Notice they're all squares, so I'm going to take out a 2 squared. I'm left with 3 squared plus 1 squared. The square root of 2 squared is 2. Oh, wow. Yuck, dippy, yucky, dippy, yucky, dippy. The next one. Again, I don't care which one you put on top. I'm 1 below, 3 above is 4. 8 above, 2 below is 10. And so again, you can do brute force, 4 squared plus 10 squared, 16 plus 100, 116. Oh, where's my calculator? Because heaven forbid you don't know how to divide that one by 4 or have any concept it's divisible by 4. If the last 2 digits are multiples of 4, you can divide by 4. Something I learned somewhere like 4th or 5th grade. And anyway, but notice these two share what? They share a 2. So I could have factored out 2 squared, and that leaves me with a 2 and 5, but everybody has a square. So I end up with 2 root 29. Yucky, dippy. Yucky, dippy. So what happens when both coordinates are on the same axis? Either delta x is 0 or delta y is 0. This is the same as just thinking a regular horizontal line or a vertical line. And so I could just say, oh yeah, look, I've got 3 left, 5 right. That's going to be 8. I have got 8 down and 5 down, and that distance is going to be 3 apart. Notice I could have plugged into the formula, but why do I want to plug in when one of the distances is 0? Just to square and do the square root. Now please notice, in all of my formulas, you will never see a negative sign. Because when I go to square something, I don't care if you think you could say -8 minus -5, but it's -3, Mrs. Simpson. No way, no how, no time is a distance ever negative. So when you're finding a distance and using the distance formula, I better never ever see a negative sign when you tell me to square. If you tell me it's -3, turkey, you better write 3. If you think it's -4, you better write just 4. Thank you very much. Now, on to circles. Circles are nothing more than the Pythagorean theorem again. The fancy definition for circle is that it's the set of all points. When I was in school, it was known as the locus of all points. Notice location of all points. That's all locus means, folks. X, Y, that are equal distance from a fixed point called the center, labeled HK of the circle. This distance we call R between the center and HK, and this distance R between the center and HK and any point XY is of the circle is called the radius. So I used a little glass bottom here and I made myself a pretty circle. Center HK, radius R, generic point on the circle. Notice I came over here and just like with the distance formula, all I did was put in the horizontal and the vertical. This is HK, XY, so this ordered pairs K in height and X in width. And so how far apart? Distance is x minus h. Distance is y minus k. So technically this is the formula for, or equation for, a circle. But now in the math world, mathematicians know that the absolute value squared is the same as the quantity squared. And so somewhere along the way, mathematicians chose that for convention's sake, we have to figure out and do just one of these, and they went with the parentheses. But please notice this is still a length. This is still a length, and even if this is -2, it really means 2, and even if this is -8, it really means 8, because it is the Pythagorean theorem. It comes from geometry, it comes from the real world, and there's no such thing as a negative length. Now, when the circle is centered at 0, 0, x minus 0 is just x squared, and y minus 0 is just y squared. And notice it's the Pythagorean theorem, only it's x, y's, and r's instead of a's, b's, and c's. Now, here is the equation of our circle in the form that we use it. Please note that the center of the circle, HK, is actually the opposite of whatever is in the negative h position and the negative k position. Why? Because this is a distance, and so we're doing x minus the x coordinate and y minus the y coordinate. Okay, so I want to write the equation of the circle. You will find that I want to subtract these numbers, so it's going to look like I'm simply, if it's a positive, I get a negative. It's a positive, I get a negative, and squared. Over here, I want to subtract, so I've shown it, but what's the pattern? When I see negative, this is positive. When I see positive, this is negative. That's what happens when you subtract. When you subtract a positive, you get a negative. When you subtract a negative, you get a positive. So down here, I'm subtracting two negatives. So negative gives me positive, negative gives me positive, and 12 squared. Over here, I'm subtracting a positive, so I get a negative. I subtract 0, so I don't even need to write it. And don't forget, a square root squared is just, the radicand. For this one, I'm subtracting a positive, subtracting a negative. So notice a positive gives me a negative gives me positive. And when you square a fraction, if you don't put the parentheses around it and you use your calculator, it will tell you 3/16. So don't be a turkey. You need the parentheses or your brain. In the next one, x minus 0, which is just x squared. I don't need to show the 0. This one's negative, and minus the negative is positive, so these are always opposite. And 0.9 times 0.9 is 0.81. And finally, you could be asked to find the center and the radius given the equation. So what was the pattern we learned? This is subtract the center, that is a negative h, gives me a positive. A positive k is really a positive on the inside, says k was really negative. And I take the square root, so my center is the opposite, 2, negative 3, and 5. Over here, when I don't see a coordinate, what does it mean? It is a 0. And what's the opposite? 1 and the square root. So the center is 0, 1, and the radius is square root 5. Over here, the opposite is negative 6. There is no coordinate, so it's 0, and the square root's 2/5. So the center is negative 6, 0. R equals 2/5. Now, I know that this has been only 3 pages of the notes, but there have been a lot of important ideas covered here that we use throughout time, and many of you honestly are confused about it from my years of experience. I see people come in and you don't understand. Well, it was a negative 3. You don't realize you were dealing with the distance. So I've gone slightly overboard, but for a good reason. You will have many more videos on chapter 1 so we can get through all the review material.